we had this audacious goal of understanding the human experience. And obviously that's a pretty large undertaking. So the question was, what constitutes the human experience? What makes humans humans? We started to look at an aspect of, can we extract a behavioral map of a person and how the person expresses certain behaviors, and then use that as a cue that something has been spoofed or something is fake.
Who's going to work with what to get something done quicker and in a more efficient way?
A big part of the response system as to how you would respond or I would respond is dependent on how you feel on my morning. Like, am I happy? Am I sad? Am I angry? Am I engaged? I'm disengaged? That matters. It has to matter for us to hold a conversation.
So welcome, Rana, to the show. Great to have you here. For all of our audience, let's start off with where you're at. You know, if I were to bump into someone in the lift, if I were to bump into you or someone from your company in the lift and they ask or I ask you what behavioral signals does, how would you explain that in one sentence?
Well, one sentence, we are in the business of understanding the human experience and then replicating various parts of it to help improve the human connection. And that's broadly speaking what we do. Obviously, the devil's in the details.
Wow. Okay. So let's expand on that sentence. How do you do that?
So, we've had an interesting history. So we started off as a research project inside of SAIL Lab. SAIL is a leading lab in the US. It's an acronym which sort of expands to Signal Analysis and Interpretation Labs. It was founded initially as a partnership between USC and Stanford, and then primarily USC led that initiative and is still an active lab inside of USC, which is University of Southern California in Los Angeles. And back when we started, we had this audacious goal of understanding the human experience. And obviously that's a pretty large undertaking. So the question was, well, what constitutes the human experience? What makes humans humans? And there's various aspects of what makes humans humans. A big part of that is how we sense things, our emotions or affect, that's a technical term, and also how we behave. So a combination of emotions and behaviors, but then it's also an aspect of how we think, how we make decisions, how we come to certain conclusions, and all of those sort of things play into what you would call human psyche. I mean, you can eventually sort of say these are building blocks of what consciousness would be all about. When we started, we sort of looked at emotions first, and emotions back in the day was very much, and I'd say still for the most part, was a capability that was derived from the spoken word. So for example, let's say if you're trying to understand a person's emotions in a conversation, you take what you call an automatic speech recognition engine, ASR, or some sort of a speech-to-text engine, and you would take the audio and convert the audio into the words using, the ASR engines, and then you would carefully analyze the words to understand the emotions the person's expressing. Is he saying or she's saying happy words or sad words, or is the person angry, or what's going on? That's how the early sentiment AI engines were built and systems were built. And I'd say even today, vast majority of the sentiment AI engines that you see in sort of deployed and in sort of use today are still very much word-based. But we've always known that's a very incomplete science. For example, if you could use a 5-word sentence, same words, and say it in 5 different ways and mean 5 different things. So if you're just focused on the words, you're going to get it wrong 4 out of 5 times. You're only going to be right 20% of the time. So, what do you do? Well, you have to focus on the nonverbal cues. You have to focus on not what you're saying, but how you're saying something, which is the pitch, the tone, prosody, pitch and tonal variance, etc. But that's been really hard. So we started to look at that problem. We started to look into, okay, how do we extract emotions from the tone and prosody and the tonal variance? And we built these early engines that started to do that, extract a range of emotions, anger, happiness, sadness, etc. And we started to measure the efficacy of accuracy of those extractions. And there's you do it by sort of gauging what the F score is, which is a combination of precision and recall. And generally, it's a score between 0 and 1. 1 being the highest and 0 being the lowest. And so you could also sort of think of it as a percentage, but it's probably not the right way to think about it. And then, so one, you have to score it. And second, you have to sort of relatively measure it against a human ability. So you would then measure a human brain's F score doing the same thing. So the human brain's ability to decipher emotions from the tone of voice real time, as you and I are speaking, where brains are doing that, is about zero point 0.8. So about roughly translates into about 80% of the times the brain is right and 20% of the times it gets it wrong. So our engine started to perform, out of the box at like about 0.5, 0.55, which is pretty good for academia. And, it was an interesting sort of dynamic to sort of pursue. But then the magic really happened when, newer sort of models came to foray with transformers, and we started to use more advanced convolutional neural networks, and we sort of went from 0.5 to 0.6, and then 0.6 to 0.7, and then 0.8, which all happened very, very rapidly within a year. And that was very, very cool, because then we achieved human parity. So these engines are performing as good as a human brain is. And then we sort of achieved a performance which was transcending human performance. And so now we're like 0.9295, which is better than a human brain. So then it makes things really interesting, because now you can sort of say, oh, wow, so let's go a step further. Let's try to understand the human behavior, which is slightly different from emotions, which is aspects such as engagement, empathy, politeness, etc. Then you can sort of go beyond from that to build more advanced classifiers that pinpoint what's happening in a conversation at a macro level. Like, so for example, if you and I are speaking with each other, can I measure your satisfaction with the interaction live in the moment? And also, would that translate into a certain action or maybe an intent? And can I predict that intent? Whether you will do a certain things based on how things are progressing. Can I gauge all of that real time? So that's kind of sort of how things progress, right? We started with emotions, we added behaviors, we've added a whole lot of other core capabilities that understand the human dynamic and the human mind. We're still very much a voice AI company, so we primarily focus all of these things from voice interactions. And those are technologies. And obviously, we productize these in many interesting ways. We can talk about that. We do a bunch of very diverse set of things with these capabilities, but obviously, the capabilities themselves are useful in many sectors.
Wow, that's a lot. That's a huge amount to cover, and a huge amount to even, start with respect to trying to sort of not just mimic, but like understand. Non-verbal cues, I think, is the key in that. From what I take, you said that most tech focuses on what we say, and you focus on how we say it. Now, to me, non-verbal cues are huge in that space, and my question would be then, in that regard, how do you? I feel non-verbal cues very much it surrounds energy.
Mm-hmm.
And the energy that someone transmits and emits between one another. And how do you look at measuring energy in a conversation or between people? Because there's tone, there's emotion, there's behavior, there's all these things that are there's a cue as an indicator to these things, right? But energy, everything is energy, so far as I'm concerned, and so far as I see. So my question would be, there's on the basis I feel there's a lot that's said in silence that can be gauged on the aura or the energy of people, interactions between people. Do you look at that?
Yeah, it's. So think of this as sort of like a audio version of a spectrograph, where you're sort of trying to see where the sort of tonal cues are landing, right? So there's different aspects of pitch and tone, and where do they land? And what we discovered while we started to measure this is, like for example, if you sort of grossly sort of think about this, like if it's like an XY coordinate graph, and there are different coordinate points, and each of those coordinate points means specific, something specific, like it pinpoints to a certain behavior, a certain emotion. What we started to look at was, let's understand what these coordinates really mean. Like, and is there corollary? I mean, a lot of that is sort of looking at data that's annotated by humans, which is you're leveraging the human brain. So you're listening to audio and you're annotating that and saying, pinpoint to me at an instance level what the person is expressing right now, what type of emotion, what type of behavior, and you do that over and over for thousands and tens of thousands, even like hundreds of thousands of audio files. Now you have a reference point. Now you see sort of, is there a corollary between, okay, so how are they landing on these coordinate points? I mean, is there a consistent coordinate that represents anger, for example? Once you do that, then you can build a model that can sort of like extract those tonal points and look for those points of reference and sort of gauge if it's anger or happiness or sadness. One of the things that we found really interesting was this extraction of emotions and behaviors was entirely language agnostic, which was really surprising for us. For example, you could be analyzing, since we do not use ASR or speech to text engine, obviously we don't really care about the spoken word. We don't process the spoken word at all. We don't actually care about what you're saying, but also we don't care about in what language you're speaking. It doesn't matter to us. And what we realize is that, the coordinates are exactly the same, across cultures, across languages. Now, but there's a caveat. The caveat is that, there's a baseline that you have to recalibrate. So for example, obviously there are tonal languages and non-tonal languages. So the tonal languages are the ones in which we kind of sort of speak in higher pitched tones in general. Everything is like a higher pitched tone. It's like a scale of, it's like a scale. If you're a musician, you would understand that, right? I mean, what's your scale? You have a natural scale and you speak here. And so when you're trying to sing a song which has been sung at a different scale, it's not your natural scale. You have to maybe just sing at your scale to get the best, make it sound better. Because if you try to adjust and if your natural scale is here, you're going to sound really bad. And what we realized that you have to recalibrate that baseline. So, but we were able to do that with relatively small amounts of data. So you could do it with maybe 30 minutes of audio from that data set. And once you recalibrate it and the engine understands what's the baseline for this data set, all of those coordinates are almost exactly identical. So once the graph shifts and the baseline changes, the coordinate that points anger is the same across languages. So then it makes it really interesting. So yeah, I mean, it's in some ways like measuring energy, but it's done through these very advanced, these models, these convolutional neural networks that looks at these patterns and extracts a variety of features from that and then classifies those features and measures it against the human sort of baseline and then learns from that.
So there's huge consistencies across all backgrounds, languages, cultures, races, etc., that are cues that just as humans we are patterns that all over the world people use.
Yes, exactly. Yeah, I mean, and we don't really understand how that materializes, but it's interesting to see that that's exactly how it is.
Wow. That's super interesting.
We're still discovering. I mean, a lot of what we're discovering now is a lot of what we thought to be special, from a perspective of being human, these aspects of like how we think, how we behave, these thoughts and how they emerge and in aspects of consciousness. What we're realizing is that they're not that special. I mean, a lot of these things are computational. So if you understand the math behind it, and you could replicate that. How that is, we don't really truly understand it yet, but that's definitely the case.
That's incredibly interesting. Very, very interesting. Wow. So let's go back for a second. What problem did you first see in the world that made you think we need to teach machines to understand emotion and human behavior from voice?
Yeah, I mean, I think a big part of the human connection is ability to have a conversation. That's the thing which sort of derives a lot of the human interaction, at least from I'd say business perspective. Like, I mean, if you think about sort of as a business today, if you're a company, you're a bank, you're a telco, whatever you are, how are you connecting to a customer? And what your connect points and what your touch points? I mean, typically a call center. I mean, everything is going digital, right? So, like, even if it's a bank, I mean, you're not visiting your bank that much. I mean, there's no physical need to go to the bank unless there's you want to access a locker or something. But outside of that, what do you really need? You can do everything over a phone or an app. So when something goes wrong is when you call the number and you're talking to a human, and that's a call center. So what has become is a situation where call centers are now sort of like the last remaining, platforms of actual real connect with your customer today. And in a call center, really, there are two humans coming together, connecting with each other, understanding each other, and trying to solve a problem. And a big part of that is the rapport that stems from a conversation. Now, conversations are really hard. Like, so for example, what we do with these voice assistants is not really a conversation, right? So when you're talking to a machine, you're giving instructions through voice. That's not a conversation. A conversation is not just solving for the NLP and NLU, which is natural language processing and natural language understanding. So you need to do more than that. Yes, you need to understand the natural language, and you also need to process it, and also need to speak it. But you need to do more than that. In order to hold a conversation, you need to understand the state of mind. And our brain does it effortlessly, right? So if you and I are talking right now, we don't really have to put a lot of effort in it, but our brains are doing the NLP and NLU behind the scenes. I mean, of course, we both speak English, so it's deciphering the language elements of it, and it's also processing the spoken word and the tone, and it's putting it all together. But a big part of the response system as to how you would respond or I would respond is dependent on how you feel on my emoting. Like, am I happy? Am I sad? Am I angry? Am I engaged? I'm disengaged. That matters. It has to matter for us to hold a conversation. How do you optimize that, right? I mean, so for us, it was sort of like, there's different ways we could help with that system. One of the things that we ended up building was, so when we were extracting these extracting these signals, we realized that if you put it together, I mean, we were able to tap into about 100 to 120 different attributes from person's audio and speech. And these attributes were, range of things such as how fast someone speaks, to various emotions they're exhibiting, to sort of like the sort of uniqueness in their voice, like shimmer and other aspects of prosodic, capabilities that may be unique to that person. If you put it together, we realize that you kind of have now a signature of that person's conversational style. And we try to understand what that means. One of the things we realize is that, hey, these things are pretty unique. So we haven't seen two signatures that look identical. So everyone has a unique signature, just like a fingerprint. And this is not a voice signature. It's a conversational signature. It's like how they converse. And that then allowed us to sort of look into, well, what does it mean from a compatibility standpoint? Are there signatures that are more compatible or less compatible? And are there signatures that when those two humans with those type of signatures, when they interact, will they have natural rapport? And also conversely, where are the signatures that will struggle to hold a conversation? And those are the different things of time we start to understand. And we put together basically a product on that thesis that is now adding value to the call center. So the product is essentially extracting the signatures real time and assessing and analyzing these signatures, and then using that information around sort of who would get along and who would have a good conversation to bring the right people in front of each other. Everything happens dynamically, right? So you don't really, play a role in it other than just speak. And obviously the agents don't do anything different other than just speak. But the AI behind the scenes decide who will pick the call up when you're calling in a system, because we already have your signature from a previous interaction. So the question is, okay, so does this really work? And does this really play out in real life? Okay, so take an example from your, real life. Two situations. Situation one is say, you're having this intense conversation with someone. You may or may not even like that person. And you're talking about something which is really testy. Let's say it's sports or politics or something like that. And you're going at it. And the person obviously doesn't agree with you, so you're literally arguing. But some weird part of it, you're enjoying. You like it. You like that argument. You like that interaction, even though the person doesn't agree with you, and you're kind of arguing. And you may have this person in your family that you do this quite often with. I mean, usually people have someone like this. What's going on in here situation like this? Like in this situation, I mean, your signatures match intrinsically to a point that you're naturally set up to have natural rapport and really good conversation, even though you may not like each other. But your signatures are very, very compatible. And conversely, you may have a situation where you just meet someone at a social gathering and you're just having a short dialogue, you're doing small talk. And sometimes that happens during when you're calling a call center. I mean, you're solving a problem. I mean, you've had multiple calls. You're very determined. You're gonna say this exact set of things, and the person picks up and says hello, and you're like, oh no, not you, no, and you're I'm gonna try again, but your brain knows not you, man. Or and so why? Because you instantly no, it's you just know this, it's not going to go well. Just the way the person answered and speaks, and so that's what we solve for with that particular use case. And then obviously there's many different things to do outside of that.
I mean, that's just huge thinking, isn't it? It's basically trying to match who's going to work with what to get something done quicker and in a more efficient way. I mean, what company wouldn't want that sort of technology in place to affect efficiencies and ultimately productivity out of two interactions?
Right. I mean, and that's that obviously is a use case that can be expanded into other
Huge.
forms. Like, so for example, soon you would be having a situation where you'd have a humanoid in your house. I mean, it's obviously a technology that is predicted to be as ubiquitous as, say, a car is. Everyone's gonna have one, and the job there of the humanoid would be more than just to do manual tasks. It would also be to connect with you and converse with you. And so it's going to require, these experiences are going to require similar capabilities that we take for granted today when we deal with a fellow human. And and so we have to build those cognitive blocks inside the brain, right? So you have to obviously do more than just understand the spatial environment and solve for dexterity, but you have to connect with this human in front of you, and you have to understand the state of mind. You have to emote that state of mind, and not just necessarily towards the goal of being a companion, but just to be useful, because I want to understand what you really want me to do. Are you being sarcastic? Are you being angry right now? So those things become really important use cases. And that all stem from like, understanding how the human brain does it, because that's a reference point, and then building a model or capability that replicates that, and then expanding those use cases.
Wow, huge. So back in those early days, what was harder, solving the technical problem of decoding emotion from voice, or convincing customers and an audience that this was something that was actually needed?
Yeah, I mean, not to say that the technology part was hard, not hard enough. I mean, it was relatively hard, but the harder part was you know, um, spreading awareness about a tool that can help, right? It's a new tool, it's a new capability, but you've never seen that tool. It's like, what is that? Right? I mean, I'm looking for a hammer that looks like a cross between a hammer and a screwdriver, and I'm not sure if I need one. And emotion AI has been been fringe science for a long time because it's been done so wrong. I mean, this whole industry that spawned on building these sentiment AI models on the spoken word, which barely worked, led people to believe it's a pseudoscience. I mean, it doesn't work. I mean, what are you guys talking about to understand emotions and sentiments? I mean, you're wrong all the time. And so when we came up with these models, I mean, there was a lot of skepticism around sort of like, the efficacy of it or the use case of it. But also specifically on the product that I just mentioned, right? That's one of the few other things that we do. So that's not the only thing we do, and we could talk about other things that we do. But we call that product pair. And so the value prop is that, listen, Mr. Call Center, what do you guys care about? You care about KPIs such as things that improve outcomes. Like, for example, hey, you want to sell more things. It's a sales related outcome. Or if it's a debt collection call center, you want to collect more debt. Or you care about the typical sort of, experience oriented and performance or cost oriented KPIs. So such as you want to improve the, first call resolution metric. So you want to resolve a situation in the first call itself. You don't want to have to call again. So there's the FCR metrics that the call centers care about. Also, you want to care about reducing the average handle time. You want to care about customer experience and CSAT score. That's really important. And you want to care about agent engagement. You want to care about all of these different things. How are you solving these problems today? Well, you are using a range of tools. You're arranging a range of tools around automation, around scripting, training of the agents. But what if for a second, you were to use a capability that rather than force fit a human into a certain situation, really puts the human in a situation where they're primed for success to begin with. And using a combination of biology and psychology and AI to sort of make that happen, and everything happens behind the scenes invisibly. But the idea is to solve for these KPIs even before a single word has been spoken by a client to an agent, just by getting the two right people together. That was a hard thing to message, right? Because not a lot of companies were looking for a solution that optimized that type of matchmaking. Now, there's been something in the industry called skills-based routing that's been around for a long time. But that's very different. The skills-based routing is a very simple algorithm that goes through, the input that the client puts in through the IVR and says, I'm calling about this reason. I want to call because my credit card is lost or whatever the situation is. So you know who to route it to, which department to route to. That's skills-based routing. But beyond that, so once you've determined that, you have a choice of 10 agents. Should we just give it to any agent, or the first agent to pick the queue, or is a specific agent on those 10 agents that are much better for Dylan, pre-matched for Dylan, because we have Dylan's conversational signature, we have all these agents' conversational signatures, we know how Dylan matches to these 10 agents, and by the way, this fourth agent in the system has a 97% match. We just know, I mean, these guys are going to have a great conversation. So if you have a great conversation, so our initial message was like, there's no good agents and bad agents. There's no good customers and bad customers. There's good matches and bad matches. So if you match the right two people, you're going to have a great conversation. And rest, everything flows down from that. Like, so if you just have a good conversation, you're going to have a better experience. The agent's going to be able to solve the problem better. The client will feel they're heard better and all that. And so that was the premise. And when we walked in, I mean, and we started to do piloting. So typical KPIs in the industry are sort of like, the wins in that is like anywhere from 1 to 5%, 1 to 3% is a big win. We started to impact this like 12 to 20%, 3 to 5 times, and so it was it was a mega breakthrough. But it was still it's still sort of communicating to the clients and the audience that here's this capabilities that are using these very advanced neural networks to extract these signals, understanding the human and the psyche behind the human and the conversational style behind the human, and then bringing the right people together. It was
Wow.
hard. It was really hard.
I
Yeah.
can only imagine that's hard. I mean, it sounds hard just listening to, but it's just mind blowing, genuinely mind blowing. So let's bring it to today. If you walk us through the behavioral signals platform at a high level, what are the main pieces and products, and who do you serve right now?
Yeah. So another interesting things to happen to us is like when we're largely focused on the CCaaS space. About 4.5 years ago, InQtel came knocking. I don't know if you've heard of InQtel. InQtel is CIA's venture arm, and they're also the investors behind very leading deep tech plays like Anduril, Palantir, Anthropic, etc. And they're typically interested in technologies that have a very well-defined commercial use case and implementation, but they can also be used for non-private sector use cases. I mean, primarily either for detecting fraud or understanding sort of like if there's an aspect of like preventing harm or maybe an aspect of national security. So that led us into sort of applying these technologies to certain other use cases. I mean, and we've done a lot of interesting work with the USG and the intel agencies, and we continue to do that. We sort of think of our capabilities as dual use, both sort of private sector and public sector. Currently, we have a few different things that we focus on. Obviously, our core technologies, which are emotion AI and behavioral AI, can be consumed through a SaaS interface, both for real time and for batch mode extraction. So this is something that is relevant for a variety of sectors. So you could just sort of use our SaaS interface through a RESTful API to do it. So that's one of our offerings. Then there is the pair product, which is a very specialized offering. It's a combination of behavioral intelligence layer and some very advanced speech analytics and this matchmaking engine that we are primarily sort of gearing towards BPOs and call centers. But it's a product that's very popular in financial sectors, etc. Now, one of the things that we've recently also done is because we've had this deep expertise in understanding the behavioral dynamic of a person, we jumped into this arena of understanding or this battle against deepfakes. Now, deepfakes has been a growing problem, but it's also it's sort of like an arms race on both sides, right? So I mean, it's sort of like a battle with the good guys and the bad guys. So as we're improving technology to detect it, the technologies that create it is also getting better. And a vast majority of the technologies on the detection side are still lagging. Like, so for example, they use, aspects such as like looking for, various sort of cues, artifact mismatch. Is there's like, is the lip movement insignificant, or is there's like, certain aspects of pauses or certain biometric signals that are missing in certain aspects of speech, and that will give you a clue. But the creation models have evolved to a point where they can sort of mitigate all of that. They can spoof all of that. They've gotten so good. So one of the things we started to look at last year was like, well, we need a completely new approach to detect deepfakes. And so we started to look at an aspect of, can we extract a behavioral map of a person and how the person expresses certain behaviors, and then use that as a cue that something has been spoofed or something is fake. And can we do this real time? So it was one of the capabilities we launched earlier this year, and in my opinion, is probably one of the most sophisticated and most advanced, methodologies to detect deepfakes. That uses behavioral mapping, and we do that today. I mean, we've built a range of capabilities around that allow us to do it not just for a speaker agnostic situation, but also we can create we can actually train a model specifically for a person's human voice, and then that delivers an unprecedented level of accuracy. That's more relevant, obviously, for persons of high, I mean, like, celebrities or CEOs or politicians who are generally the target of the situation. So I think so. Those are the different kind of things that we're doing. I mean, so we're sort of dabbling in both sort of the consumer sector, but also the enterprise. So we sort of have a mix of both, and a little bit of the government side as well.
Interesting you talk about deepfakes, because it was interesting to hear, how your system actually spots a fake voice, and what is it that you're doing differently from traditional audio forensics to spot that? Because as humans, we're good liars, right? Like
Yeah.
from young age, we're taught we don't want to get in trouble, so we lie.
Yeah. So, um, you know, for the most part, the tools today. So let me tell you how other systems work and why they're inadequate as a point of reference. So to how we do things differently, right? So the tools today are looking for certain biomarkers that are typically present in the natural voice or the human voice, and but are absent in the synthetic versions of the human voice or the deepfake versions of the human voice. Now, these biomarkers can also be thought of like some inconsistencies, and that are present in the natural voice. And but when you're creating the fake versions of that, you're losing those. And the tools are really looking for those biomarkers. I mean, they're looking for those biomarkers, and when they don't find them, they're like, "Aha, this is fake." The problem is that now you could spoof those biomarkers. You could spoof those biomarkers and insert them at the right places, so the tools get fooled. Like, I mean, even without the the situation where the biomarkers were missing, I mean, the human ears were obviously completely unequipped, right? So you still needed AI to even look for those biomarkers, because to us, we are so inadequate in terms of understanding the difference between real and fake that I could create a fake audio of a family member of yours from something that I can get from a TikTok feed they did or IG feed that did. So it's just a few seconds. And if I play that back to you, you'll not be able to tell the difference, right? So we're pretty bad. The human ears are pretty bad. So that's a very low bar. But AI is better, right? So it can look for those biomarkers. Now, so if the AI can spoof those biomarkers, then how do you play that game? How do you even look for deepfakes? And so our approach was to not rely on just the biomarkers. What we do is when we're looking at audio, we quickly sort of like extract a behavioral signature of that person. And we understand exactly how that person's expressing different behaviors, different emotions. And when we see a variation and deviation from that, we understand that something is fake. And that's a very, very, it's very difficult to spoof. Like, so you can create a fake sounding, a real sounding voice, which is fake, but you cannot spoof those behaviors in the tonal and the prosodic aspects. It's extremely difficult, or almost, I'd say, not possible today. So with that, you now have a tool that works much, much better.
So, what exactly are you looking for in the voice? Is it pitch? Is it rhythm? Is it micro pauses? Intensity? What are the behavioral signals that matter most?
It's a combination of a lot of those different things. I mean, we're looking at multiple different attributes that are unique to that particular person's behavioral signature or that conversational signature real time. I'll give you an example. Like, so for example, anger. People think like I'm just making this using this as a point of reference. Like when you sort of think that when you're angry, you're always going to speak loudly, or in a higher pitched tone. That's not true. A lot of people go quieter when they're angry. There's some people who talk slowly or slower when they're angry, and there are others who will talk faster. And so there's a lot of variations in there. So when you put it all together, when you look at it and say, okay, I have this unique aspect of like, okay, this is what Dylan's conversational or behavioral profile looks like. And so we look at all of those attributes, and it's not just one cue. It's like, all of these cues sort of put together. That gives us an understanding that something's off. This is not him. It sounds like him, but it's not him.
Wow. Okay. That's
We're now able to also do this at a fairly small segment. Like, so we could identify a 2-second segment in a larger audio that has been spoofed or is fake. So it doesn't have to be, a determination that says that somewhere in this entire audio, something is fake. Now, we'll tell you exactly where. We said this 2-second segment is fake, and here's why. We can explain it.
That's incredible. And where are you finding the most demand for this service? Like what type of industries, what type of areas, who wants this most?
So, that's a good point because while the problem is accelerating very rapidly, there's still lacking on awareness side of things. Like, just to give you a perspective, in 2023, I just have the numbers for the United States, but, the dollars impacted through scams pertaining directly to deepfakes was about $500,000. And, in 2023, that was 8 billion. 24, it was 8 billion. And in 2020,
no. 500,000
right,
to
8 billion. Unprecedented, right? And so so this is sort of and in 2025, I think we crossed that number in the first quarter, and so we'll see where this number ends up. So there's been cases where things are more visible. Like, for example, there was this situation where a Zoom call happened, and it was a Singaporean organization where a CEO asked the CFO with other members present in the video Zoom call to transfer $25 million in an account for a business transaction, and that was all scam. Everybody was fake, right? And the person got fooled. There was, I don't know if you've tracked this story with Marco Rubio, our Secretary of State, where there was a spoof account, the person spoofing Marco Rubio in various signal calls and other meetings, and that got undetected for 8 months. I mean, Secretary of State, for Christ's sake, right? I mean, and you'd think we have good technology, but wow, it's a big problem, right? And so, so with that, it's a rapidly growing problem, but I think, overall awareness is still lacking. Where it is initially sort of being adopted is obviously, where the conversations of high risk, like, again, in call centers, it's high interest, capability, but also, people who are specifically worried about fake content that represent their brand. So that's a particular use case where, you're incented to scour through, or you're going to apply to work with a service that is going to identify and remove content that represents you, but it's not you, it's fake content. So that's another area of interest. I could potentially also sort of see a use case where there would be a live checker in every video conferencing call you do, because otherwise, how do I really know it's you? and how do we even do business remotely? If I can't trust you, even when I can see you and hear you, then the only way we can actually do business is when we're in person. Well, we can't go back to that again, right? So how do we do it? Well, then there needs to be sort of a live assessment, live checker. So there's a whole range of use cases. Currently, for the most part, we're delivering this capability again as a SaaSified API interface. And so we're allowing people to use it in a variety of experiences, but they're embedding into their experiences themselves. We obviously have on a roadmap a variety of other sort of package capabilities that, can even bring this to a consumer. So you as a consumer may be interested in just because you're consuming content over YouTube or social media and that's influencing you, and you may want to understand if it's real or fake. It's really interesting 30-minute clip of Jordan Peterson talking about something which is really controversial, and you may or may not like that person, but you're now curious, did he really say that? Is it real or fake? How do you do that, right? So creating a tool that allows you to do that, maybe it's like, through a browser plugin or something else.
So let's make this tangible. Can you share a story, I mean, anonymized if needed, where your tech changed the outcome of a call center?
Yeah, I mean, there's many situations to talk about in that. I mean, I would use since we've had a longer sort of I'd say footprint with our pay product. I mean, I'll give you an example. Early days. So this was a large public bank of a European nation. Obviously, for privacy reasons, we don't disclose the actual name of the bank or the country. Large public bank, and they had a call center that was about 120 130 agents that was primarily focused on working with clients who were kind of falling behind and the risk of getting default. I mean, something was happening, they're missing their payment, so this is not that they're not defaulted yet, but if something doesn't happen, and the purpose of and the goal of these agents is to call them, work out a solution, right? So that's sort of like the purpose. When we started to work with that, we really loved this use case, right? Because we figured like, okay, this is the ultimate human to human negotiation use case, and how can we impact a situation like this where we can bring in sort of our technology sort of to maximize the rapport and the human connection. When we implemented our capabilities in that call center, we started to measure the before and after in terms of the ultimate outcome in that interaction would be a successful loan restructuring agreement, because obviously these guys were struggling. So you have to come up with a different structure on how you would not struggle. And that gets translated into a dollar amount that is potentially either saved from default or earned by the company, again, because it's not defaulted. And so we started to measure the before and after. And within 4 months, when we sort of looked at the delta, each agent was on an average collecting about $500,000. Actually, $1.5 million in additional revenue per agent per year. So if you sort of look at that 130 agents, you do a math, that's $400 million of upside created by a product that you don't see, you don't hear, and you don't have to do anything differently about. You just don't, I mean, you're just there. I mean, it's just sort of like,
It's just matching.
making a decision. It's just matching. It's sort of deciding like, you're going to call this person today. You're going to call, that's all, that's it. That's all you need to do is just, rather than call this, call this. And so I think that was a game changer. It was one of our early deployments. It also allowed us to accelerate our product portfolio. So I think there's many stories like that, but we're really proud of that.
And rightly so. Congratulations on that. That's an incredible number. So
Thank you.
I mean, moving on to like ethics and bias and emotional manipulation, right? Anytime you talk about machines reading emotion, people just generally worry about two things, right? Bias and manipulation. So how do you make your models work fairly across different genders, cultures, accents? And what are the limitations you're sort of upfront about?
Yeah, I mean, see, this is a quintessential problem of model training. Training is dependent on data, and the quality of the data or the lack thereof is where the bias stems in from, right? So you have to build diversity in the data set, right? So if you're working, if your model is going to learn based on certain patterns, you want to make sure that there's diversity of patterns in there. Otherwise, it's going to be very biased towards a certain pattern. And that's really hard, right? So a lot of the data we create ourselves, and some of the data that we get from our client side, and we process tens of millions of phone calls at this point. Um, you know, it when you're doing it, you have to make sure, like, the annotators don't have a bias. The data sourcing doesn't have a bias. I mean, the model algorithm itself doesn't have a bias, and that's a continuous battle. The good news is that, okay, first off, I mean, it's not us just faces a problem. I mean, every company that is doing some sort of AI model training has this issue to deal with. The good news is that if your model is biased, it is an inferior model and eventually gets weeded out from the market sooner or later, right? That's the good news, because, like, let's say if you have a biased model and that has a bias towards a certain cultural group or a racial group or sex and all that, it's just going to be inaccurate at the end of the day. And it will come out. And because the inaccuracies will come out, people will point it out, and eventually it gets thrown out of. So there's a natural inbuilt pressure to sort of do things right. Um, and especially for a commercial entity like ours, right? I mean, we don't really have any other specific agenda. And now, I mean, on top of that, but I mean, there's a higher bar, right? I mean, there's an aspects of moral responsibility and ethics, right? Now, a lot of that comes from, ensuring that you're building very, very powerful tools. Obviously, just like any tool, I mean, it can also be used for nefarious purposes, right? I mean, hammer is a very useful tool, but you could use a hammer for really bad things, right? I mean, but that doesn't necessarily mean that a hammer is a problem. The problem is, like, you need to sort of regulate who uses it and how it's being used, and etc. So there's a lot of choices. I mean, so we've had to make choices in terms of, like, where do we apply it? Who do we apply it to? Like, and where are some of the lines we don't want to cross? And we make those decisions. And I think, again, as I said, I mean, if you're focused on the long play, those things are not no brainer. I mean, if you're just focused on some short wins, I mean, maybe you will make some compromises, but it doesn't play out in the long run. I mean, this is a long play game.
Amazing. I mean, it's super interesting, and it's a huge debate, a never-ending debate, because ultimately, humans have bias, right? So it's gonna be an ever-evolving space to, like, for companies to be able to, like, not just make better, but, like, ensure that the right thing is done. And as you say, it's incumbent on the human to use the technology well or not.
So I'll leave you with a thought, right? So yes, humans have bias. So there's a very interesting aspect, right? So we're not born with a bias. We're born with a clean slate, and then we build those biases through our environment. The first source is our parents and our family. The second source is our friends, and the third source is the environment, right? So we're building those biases. AI learns the same way. Machine learning learns the same way, through patterns and through environments. And it's building and codifying those biases, right? Is the solution to have a non-biased human? Well, that non-biased human is also biased, because you're just biasing towards your bias, and your view of non-biased is the non-biased human. The solution is to have a diversity of biases. And that's really the solution. It's like, say, okay, you can't really have a non-biased person. The person by nature, the intrinsic nature of the person is to have a bias.
Yes.
And you could shift the bias. You could say, I'm going to shift your bias from here to here, because in my worldview, that's the right bias. But you still have a bias. So the problem, and the same problem with AI models, right? I mean, and so, I mean, a lot of what we could do, I mean, obviously there is a certain moral and ethical code, and those should be codified. I mean, there's some things that are non-negotiable and no-brainers, and so those things. But outside of that, I mean, there is going to be a natural evolution. So I think there needs to be, a diversity of models out there that do things differently, and that eventually allows for a more sort of fairer society in the system. Like, I mean, but the things that I was talking about was more sort of like in the no-brainer stuff. Like, when you're looking to understand certain things and emotions and expressions or decisions or actions, make sure you take an adequate representation of the human population. Different ages, different different sexes, different cultural groups, because there is variance in there. But if you're going to take one sector of that and your model's trained on that, it's going to be wrong. It's just going to be inaccurate. And that will be weeded out of the market, as it should.
100% agree with you. It's super interesting. So listen, closing and sort of rapid fire questions here for you. What's the most overhyped idea in AI right now, in your opinion?
I think the most overhyped idea is this whole idea of agenticization, in my opinion. I mean, because I think it's really sort of like, saying, let's use AI to automate, which is, yeah, of course, yeah, duh, right? I mean, but this whole aspect of I'm going to just focus on agenticize. I mean, that's what software development's been all about, is automation, is streamlining. And now we have more sophisticated tools that do it with a little bit more autonomy. So I think really, really powerful capabilities, but extremely overhyped.
What's the most underrated signal in human communication that you think we should pay more attention to?
I think that's a hard one. I think I personally feel like, we don't really measure, we measured a lot of other aspects. We don't really sort of measure certain aspects of engagement really well. I think, we're looking at a lot of other visual and verbal cues when we're interacting and talking, but we're talking about, like, we focus a lot on emotion. They're talking a lot focused on other aspects and dynamics, but is the person really sort of connected or engaged? As long as the person's being polite and saying the right things, doesn't mean the person's engaged. And I think it's very underrated. I think it plays a massive role into pretty much every aspect of conversation, business outcome.
Amazing. Rana, this has been absolutely fascinating. It's been brilliant. So for anyone who wants to explore behavioral signals, pair, Ola API, where's the best place for them to go next, and how can they get in touch with your team?
Yeah, start with the website, behavioralsignals.com. And obviously you could reach out to us. We do, make it a point to publish at least a couple papers a year. We are still very much focused on research, so would love to sort of collab with you on that. I mean, if there's an aspect of research that is of mutual interest. But yeah, obviously, would love to hear from you.
100%. That's fantastic. Thank you so much. And look forward to hearing and seeing how your company progresses. Fascinating space. Thank you so much for your time.
Thank you, Dylan.
Thank you.
Appreciate it. Thanks for having me on the show.
Yeah, absolutely.